Welcome to Cayley hash functions. In this video, we would like to introduce you to one of the most interesting applications of graph theory in cryptography. We will discuss hashing, Cayley graphs, Cayley hashing functions, and collision reduction problem.
Cryptography is basically having two keys, one key at the sender side and the other is on the receiver side. And the plain text is encrypted using an encryption algorithm that is on the sender side along with the key, and this plain text that is now encrypted is transmitted to the receivers, which is decrypted again using a decryption algorithm at the receiver side along with the unique key that the receiver has. Hashing is the process of converting input data of any size into a fixed size string of characters, typically for the purpose of data storage, retrieval, or our main focus, which is security verification. As you can see here, the plain text is converted into a hashed text of fixed size using the hashing algorithm or the hash function. In this slide, you can see an example of a Cayley graph. A Cayley graph is a visual representation of the connections between elements in a mathematical group. It uses vertices to represent group elements and edges to show how the elements are related by a specific operation, like group multiplication. They are crucial for understanding group structure and are used in fields such as computer science and cryptography.
To understand Cayley graphs, we first need to introduce what is a group. A group is a set together with a binary operation and has three main properties: associativity, existence of a unique identity element, and every element in the set has a unique inverse element. Generators of a group are the elements that, together with the binary operation of the group, can generate all other elements of G. Now let's see this example. Let G be a group with the set containing 1, 3, 5, 7 and a star binary operation, where for A and B in G, A star B is the remainder of A multiplied by B, then divided by 8. The set of generators in this group is the set containing 3 and 5. Now let's construct our Cayley graph. The vertices of the Cayley graph are the elements of the group G. Now every element X in G is connected to X star S, where S is an element from the set of generators S. And every edge has a weight of S. Now 1 star 3 is equal to 3, so we draw the edge 1, 3 with a weight of 3. And 1 star 5 is equal to 5, so we draw the edge 1, 5 with a weight of 5. Now we repeat this for the rest of the elements of the group for each one of the elements in the generator S. And we draw the edges and we finally get our Cayley graph. Are you ready to see how Cayley hashing functions are constructed? Let's see these initial steps. First, we need to identify the set of characters in the text to be hashed. Then, we choose a group with a set of generators with the same cardinality as the character set. Third, we need to identify the set of generators S to be used. And finally, we need to define a mapping that maps each character from the character set used in the text to an element from S. Now, consider the group of integers modulo n under addition, where n is a prime number. Now consider n to be 7. The set of generators of G is the set S, which contains the elements 1 and 2. Now let X be the string to be hashed in binary, where X is 0, 1, 1, 0, 0, 1. Now define a function f from A to S, mapping 0 to 1 and 1 to 2. This means that now every character in X is mapped to an element from the group G. Now take the images of the characters of X one by one under the function f and add them under the group operation addition. This results to 9, and 9 mod 7 is equal to 2. 2 is now the hash value of X. Thus, each of X is equal to 2.
Collisions occur in hashing, And collisions occur when two different texts with similar context, such as John Smith and John Doe, shown in the slide, are hashed to the same value. As you can see, both of them have the same first name, and both of them are hashed to the same value, which is 153. And this is a problem, as 153 now represents two different texts, and that is why we use graph theory to find a good group and generators to avoid too many collisions and keep the hashing efficient. Now we'll see how two different pieces of text represented by these two people are hashed and stored based on their context when they are so similar.
What's your name?
Charlotte,
What's your class number?
graduating senior,
What's your major?
computer engineering.
Thanks.
Bro, that's my chair.
No, it's mine.
It's my spot.
It's mine.
It's my chair.
As you've just seen, when both texts had similar semantics but slight differences, so for example, having two texts with the same letters except one or two maximum, which are different, they collided when they were hashed because simply they were hashed in the same value. And our aim is to reduce this in Cayley hashing, which basically is hashing using Cayley graphs.
Thank you for watching our video. If you are excited to know more about graph theory, please don't hesitate to reach out to us.